Alright, so here we are with the 8.1 notes on measures of central tendency and variation. Some of this is probably going to be review, like mean, median, mode, that kind of thing, but some of it is hopefully going to be new and interesting. Let's see. It is kind of a longer set of notes just because of the fact that we're going to learn something by hand before we learn it on a calculator. So, anyway. So our objectives are to find measures of central tendency and measures of variation for statistical data, and examine the effects of outliers. Super. So words that you'll hear are expected value, probability distribution, variance, standard deviation, and outlier. So to get us started here, we're talking about a mean, median, and mode and range for this data. So your mean, remember, is adding everything up. So we're going to take 6 plus 9 plus 3 plus 8 and dividing by the number of numbers. So there are 4 values here. And so if we add them all up and divide by 4, we're going to get 6.5. Alright, so that's our mean. Then we have our median, and our median is listing them from least to greatest, so 3, 6, 8, 9, and then finding that middle value. Well, there isn't a middle value because it's between 6 and 8. And so what you do is you take 6 and 8, the two middle values, and average them, or find their mean, and you get 7. So 7 is the median value. If there's an odd set of data, it's going to be actually that middle value, but since it's an even set of data, it is the average. Then we have our mode, and you've probably had this one before, but it's the number that occurs most often. In the data. And so as we look at this one, it turns out there is none for this one. Now some of you might say, but then all of them are potentially the answer. Well, no, definitely looking for something out of the norm. And in this case, they're all happening once, so that is the norm. Then your range just means that we're talking about the difference between the highest and the lowest value. So highest value minus the lowest value. And so the highest value is 9, lowest value is 3, and so we have a range of 6. And again, those ones are practiced a lot in previous classes, so hopefully we have most of that down. So then we have something called a weighted average, or an expected value. So your weighted average is a mean that is calculated by using frequencies of data values. That just means the number of times that something happens, your frequency. So we have 30 movies that are rated as follows. So notice that we have 8 movies that got a 4-star rating, 12 that got a 3. And so it's actually easier if we look at these as numbers instead of stars. So 4 would be for this one, 3 here, 2 here, 1, and then 0. And so the weighted average means that you are going to take each of this set of data and multiply it by its rating. But before we can get started on that, we are going to have to change these into their probabilities. So 8/30ths, 12 out of 30 movies, 7 out of 30 movies, etc. And so your weighted average is going to be 4 times 8/30ths plus 3 times 12/30ths plus 2 times 7/30ths plus 1 times 2/30ths, and then technically 0, because that's not really going to do anything. So if we go ahead and calculate that, and of course I wrote this wrong, okay, 30ths. Okay, so if you use 30 in the denominator of all of them, that means that your average weight of these 3 movies is going to be a group of 2.8 stars. So it's kind of like saying you're going to get a 2.8 star rating if you are within this group. And of course there are more that get more and some that get less, but there you go. All right, so expected value is the weighted average of all the outcomes, and so that is very much like what we did here in this example. So expected value is very much like the weighted average. And then your probability distribution is the function that pairs each outcome with its probability. So we'll kind of see how that works here. So the probability distribution of the successful free throws for a practice set is given below. So apparently 3 out of 20 of the throws were none. Sorry, to make 0 out of the free throws, that happened 3/20ths of the time. Making 1 free throw was 3/20ths of the time. Making 2 free throws was going to be 1/5 of the time, and making 3 was on half of the time. I'm not necessarily sure how many total free throws we're going with. Like, did they do 5? I don't know, but it looks like probably just 3 total. So we're going to find the expected number of successful free throws for this data. So this one's kind of backwards from the last one, but it's 0 times 3/20ths. To that, we're going to add 1 times 3/20ths. To that, we're going to add 2 times 1/5. And then to that, we'll add 3 times a half. So again, in this set, we're expecting 2.05 free throws to be successfully thrown. So out of 3, that's very lovely. All right. So the next one is a box and whisker plot. So again, hopefully you've seen these. Basically, the best idea is with a box and whisker plot is that it shows the spread of the data. Okay. So the idea is that it's not just this average. It's talking about the spread throughout, how many data points are within there. So for instance, half of the data points are going to be between this number and below. Half of the data points are going to be between this number and above. And so that's your median. We also know, for instance, half of the data is going to be within these two ranges here. And then, of course, these are called quartiles, literally because the box is broken, the box and whisker is broken into 4 parts. So if we have all 4 of these parts, that's why we're talking about quartiles or quarts there. Quarters of the data. So let's take a look at what this says. 5 key points are given. We've got your minimum, so that would be the lowest value that you have. Maximum, the highest value that you are given in your data set. Median, we talked about earlier, and remember if it's an even set of data, that means that it's an average of those 2 numbers in the middle. Then what happens is we eliminate that median, and then we talk about the median of that range of data. And then we also talk about the median of this upper range of data. And so that's actually why this is called the the interquartile range, because we are talking about quarts, and it's the inner part of those quarts. So, again, there's a median, but then you end up taking the median of the lower half of the data and a median of the upper half. All right, so the quartiles are the medians of the lower and upper halves of the data set. Already talked about that. If there is an odd number of data values, you do not include the median in either half. So we kind of talked about that. The median is eliminated if there's an odd set of data. And then the interquartile range, or the IQR, is the difference between the first and third quartiles. So again, that's that box out of the box and whiskers. So, not the whisker part. All right. So we're going to go ahead and make a box and whisker for all of this data. So the first thing that you want to do is put them in order from least to greatest, your numbers. So we're going to take the time to list them from least to greatest. Let's see, least value 4. And then there's a 5. 2 6s. 7, and then an 8, and another 8, and a 9, and a 10. So that is your list of values from least to greatest. So of course this is our minimum value. And this is our maximum value. Then we have our median. Let's see, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so we do have a middle number. So that's going to be right here. All right, and then remember that if there is an odd number, which there is, we're going to eliminate the median and find the lower quartile by doing the middle number here. So middle number between here is actually 5.5 for the lower quartile. And then between 8 and 9 up here is going to be 8.5 for your upper quartile. So taking into account all of these, many of you will try to put your box and whisker on the graph, actually, but it's supposed to be above it. So if you take a look at this image here, notice that the image is actually above the line versus on it. So just something to remember for that. Now, if you ever draw it on it, fine, but then I just know you didn't pay attention. Okay, so here we are on the minimum, which is at 4, and the maximum, which is at 10. We know that our median is 7. I'm going to make a line there because we are trying to make a box. The lower quartile is at 5.5, so I'm going to put that here, also making a box. And then 8.5 is where our upper quartile is as well. So then we kind of connect it all, and there's our box and our whisker. Let's say that depending on what's happening, you don't actually have the best way of showing these numbers, like it's not very clear, maybe the number line is too small or something. You can in fact actually put the numbers above where you're seeing them. So I can kind of reiterate that that's 10, I can reiterate that this is 7, and then just be very clear about what each of these values is so we don't have to guess. Then your interquartile range, remember, takes your upper quartile and your lower quartile and subtracts them. So apparently that box has a range of a value of 3. So here is our box and whisker, and there is our IQR, interquartile range. All right, so a measure of variation is a value that describes the spread of a data set. So the most commonly used measure of variation are the range and the interquartile range, and the variance, which we'll talk about in a minute, and then also standard deviation. So we've talked about range and interquartile range, but now we're going to move on to variance and standard deviation. So the variance is denoted by this thing here, which is actually our theta squared, our sigma squared. But basically it just looks like a cursive O kind of thing there, but it is a Greek letter. So either way, that's our variance. It's the average of the squared differences from the mean, which literally means we will be subtracting, meaning difference, and squaring the values once we find them. The standard deviation is denoted by just that symbol itself, so notice the difference between it is that one of them is the squared version of the other. So it's denoted by the fact that it's the square root of the variance and is one of the most common and useful measurements of variation. Because basically, from the standard, how much does this value or this set of values deviate? That's what we're looking for. So just so that we are aware, if we have the variance, and we take the square root of that number, we're going to end up with the standard deviation. And again, that is because the variance is denoted by that theta value squared, that sigma value squared, and then the standard deviation is actually just that value all by itself, which of course would happen because the square and square root would cancel. All right. So We are going to actually calculate these. Again, I mentioned we're going to do this by hand, which is going to take a little bit longer, but then I will show you at least the images from a calculator of how to do that, so it's not as time-consuming later. So, low standard deviations indicate data is clustered near the measure of central tendency. Just means if you have a low standard deviation, that means it's not deviating from the standard very closely, which means it's going to be clustered. If that's what you want, then that's good, right? Being close to the average is usually, helpful when you're trying to make clothing sizes and things like that, right? So, anyway, but sometimes, of course, it's not helpful, so it just depends. Whereas high standard deviations indicate the data is spread out. It is more deviant from the standard, spread out from the center. So, what we're going to do to find our variance and standard deviation is we're going to find the mean of the data. So we have talked about mean, but we haven't talked that mean is actually given by this symbol for mean. And that symbol is just an X with a line above it. It's called X bar. Anyway, then we're going to find the difference between the mean and each data value and square it. So again, the difference, we talked about the subtraction between the mean, so that's what we found in step 1, and each data value that's given. So we're going to subtract those. And then we square them. Then we're going to find the variance by adding all of the squares of all of the differences from the mean. So all of the results from step 2, we're going to add them all up, divide by the number of data values, very much sounds like a mean, and then of course find the standard deviation by square rooting the variance. I know, sounds like a lot, but here we go. This I already mentioned, but remember that the mean is actually given by this X bar symbol. So anyway, and then sigma here is this guy. I sometimes call it theta, but theta is actually this guy, so anyway, not that one. All right, so we're going to find the mean and standard deviation of all of this stuff. So let's find the mean. So the mean is going to be all of these added up together, and then divided by the fact that there are 9 of them. And again, that's going to be your X bar or your mean. So the value is 63, which we will be dividing by 9. And so we end up with a mean of 7. So that is going to be a very important number, because what we're now going to do is take every value here and subtract that mean. So 6 minus 7, and 8 minus 7, and 7 minus 7. And let's see, 5 minus 7, 10 minus 7, 6 minus 7, 9 minus 7, 8 minus 7, and 4 minus 7. So all of those values are going to get us, let's see, 6 minus 7 is going to be negative 1 that we'll be squaring, which is just 1. 8 minus 7 gets us a 1. Oops, where am I putting that? That will end up squaring, which is just 1 again. 7 minus 7 gets us a 0, which will square, so hey, that's 0. 5 minus 7 gets you a negative 2 squared, but doesn't really matter because it's still going to be a positive number, so 4. 10 minus 7 gets you 3. 3 squared is 9. 6 minus 7 gets you negative 1, but squaring that is just going to be 1. 9 minus 7, which is going to be 2. 2 squared is 4. 8 minus 7 gets you a 1. 1 squared is 1. And 4 minus 7 gets you negative 3, which when squared is 9. So I'm just going to write all of these down here so we have that. So the next one is to find the variance, and so we need to find the average of the last row of the table. So I need to add up all of these numbers, so 11049. 1419. So that becomes 30 divided by 9, and so our variance is going to be 3.3 repeating. All right, now that we have our variance, all we need to do is take the square root of the value that we got, and then we will have our standard deviation, so 1.83. So our mean is 7 from the previous, or from that first operation. So 7 here. And then our standard deviation was 1.83. So what does that mean? Well, an outlier is an extreme value that is much less than or much greater than the other values. Outliers have a strong effect on the mean and the standard deviation. What happens is, to determine an outlier, you look for data values that are more than 3 standard deviations from the mean. So again, looking at our previous example, that would mean the mean is 7, so that would be your middle, and then 3 of these standard deviations above and 3 of them below are a lovely range that we're expecting. But if it's more than that, then that actually ends up being an outlier. So we're going to examine this idea of outliers, and we're going to find the mean and the standard deviation for the heights of 15 cans, and we're going to identify any outliers and describe how they affect the mean and the standard deviation. So this is a lot of data values, and so if we imagine the process that we just did, I'd want you to find the average of this and then end up subtracting every single one of them, squaring every single one of those differences, and finding the average of that. Well, it turns out that you don't have to, because there is, in fact, this idea of doing it with a calculator. So what happens is you go to the list, and remember that that's under Stat, and then Edit. And so if you go to Stat and Edit, then you can enter in all of your data pieces. So we get to enter in all of these numbers exactly as they are. Then what happens is you get to find the mean and standard deviation by going to Stat button, then the Calc menu, so that means you have to scroll over, and then you get to select one variable statistics, and all of this comes out. So you don't have to do all of that addition and subtraction. So that is very helpful. So what happens is this is your mean, and then this is your standard deviation. And then right here is your number of terms. If we look at a few of these other things, this just means that this is the sum of of all 15 values. This is the sum of all 15 values squared. Anyway, these don't necessarily help us in what we're determining right now. So the mean, as they show here, is about 92.77, so thinking of that with all of these. And then the standard deviation is about 0.195, so they're saying that that is the deviation from that standard mean. So how do we identify the outliers? What you need to do is go with your mean, which we found here as 92.77, right? And then from there, we need to go out 3 of this 0.195. So 0.195 times 3 gets you 0.585. So what we're going to do is we're going to add 0.585 and subtract 0.585, because that is 3 standard deviations away from that mean in the middle. So 3 standard deviations. So that means that generally we would like our data to be between 92.185 and 93.355. And then it would be kind of what we would say maybe normal data. So if we look at that, that means 92.185 and 93.355 are our outliers. Our range of values. And so if we look back at our table, we're looking for ones that are greater than or less than that. Again, we're looking for ones that are outside of these values. And so literally the only one that is anywhere near that is going to be 92.1, which is too small. It's less than 92.185. And so because of that, that is our outlier, so 92.1. So what you get to do then is remove the outlier from that list. So again, you go back to your list by going to Stat and then Edit. You remove that 92.1, and now you have 14 pieces of data instead of 15 because we've removed 92.1. And so what happens? The outlier in the data set causes the mean to, let's see, 92.82. Turns out that this is backwards of how I'm trying to think of it. So the outlier in the data set causes the mean in the data set, this outlier, so with, okay, so I just have to think about it the other way, sorry. The outlier in the data set, so this data here, causes the mean to decrease from 92.82 to 92.77. And the standard deviation to go from 0.077 over here to 0.195. So we're actually talking about increase. So the outlier, again, causes the mean to decrease from 92.82 to 92.77, but the standard deviation increases, which makes sense, because if you have that outlier pulling the data out more, you are, in fact, going to have this larger deviation from that standard. All right, so that's the idea. Again, kind of a bit for figuring out your calculator, but we have done this idea of going to Stat and Edit and putting our lists in before. Just the new calculation now is this thing of one variable statistics and knowing that we want this row, this one, and sometimes that row. All right. So those are our measures of central tendency and variation. So hopefully we have a little bit more understanding of how to find the measures of central tendency. Again, those include variance and standard deviation now. And then examining those effects. Does it increase or decrease whatever it was that we were talking about?